Hello dear friends, how are you all? I hope you all are good. Welcome to Design Tech VLSI. So in Design Tech VLSI, we already learned the simulations process. So हमने simulation process का 10 lectures upload कर रखा है. Now we are going and proceeding further in TSMC 65 nanometer technologies का हम further notes देखेंगे और TSMC 65 nanometer में आपको layout बनाना सिखाऊंगा कि क्यों layout बनाएंगे. एंड ये जो होता है ना, ये जो पीडीके होता है, तो पीडीके को हम कहाँ पे यूज करते हैं, क्यों यूज करते हैं, प्रोसेस डिजाइन किट होता क्या है. सो चलो टाइम वेस्ट नहीं करते और स्टार्ट करते हैं आज का लेक्चर सीरीज. ओके, आई होप आपको अगर ये वीडियो सीरीज पसंद आती होगी ना, तो लाइक शेयर सपोर्ट जरूर कर देना. इससे मुझे कॉन्फिडेंस मिलता है और आगे मैं और बहुत सारा वीडियोस बना पाऊंगा. तो मैं एकदम जीरो से स्टार्ट करूंगा लेआउट एंड विल लर्न टुगेदर. ओके, लेट्स स्टार्ट. सो yeah, so we are learning the layout of inverter. So this we are going to learn layout of the inverter. First of all, I will tell you how it's look. Inverter layout. See, a normal inverter layouts is look like this. Okay, and we'll make it from the starting. Okay, so okay, let me change the background. Yeah, okay. So inverter layout we are going to learn. So we all know that the inverter is nothing but is the combinations of PMOS and NMOS. So this is your V in and this is your V out. Okay, we already know about this, and this is 1.5 to 2 times greater than, suppose the size is alpha, so it's 1.5 to 2 alpha times of the NMOS, and this is your PMOS. And this terminal is this is your source terminal, this is your drain terminal, this is your drain terminal, this is your source terminal. The source of the PMOS is connected to VDD and the source of the NMOS is connected to ground, and drain interlinked. And here we can connect the capacitor for taking the output. Okay, this is the general term. So what is, see, we have a lots of PDK file. We have a lots of PDK file. What is the meaning of a PDK? PDK is nothing but it's a process design kit. Okay, in process design kit, we'll have a lots of library file, left file, and many other spice file, some verilog file. Okay, whatever. See, actually, what industry do? So industry define this file according to their manufacturing process. And if you will use this library, if you will use this library, use this particular file, they will easy to manufacture your circuit on wafer. Okay, so if you are downloading Cadence, so Cadence by vendor, you will get a 3 PDK in terms of GPDK, 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 45 nanometer technology, 90 nanometer technologies, and 180 nanometer technologies. तो these all are ना, it's generic process design kit. मतलब ये आपका इंडस्ट्रीज कभी भी मैन्युफैक्चर नहीं कर सकता है, ये सिर्फ आपको सिमुलेशन से एक मिलता जुलता सिमुलेशन दे देगा. बट आपको अगर मैन्युफैक्चर कराना है इंडस्ट्री में, तो आपको मूव करना पड़ेगा या तो TSMC 65 नैनोमीटर टेक्नोलॉजी, या तो SCL PDK, ओपन PDK, स्काई वाटर PDK. ओपन PDK भी मैन्युफैक्चर होता है स्काई वाटर. ओके, सो दीज ऑल आर दी प्री डिफाइंड, मीन्स ये इंडस्ट्री फाउंड्रीज के द्वारा डिफाइन किया हुआ फाइल रहता है. जैसे कि मैं अब अपना एक सर्किट्स बना रहा हूं, सपोज आई हैव अ कैडेंस, मैं सीमेटिक्स बना रहा हूं और मैं लाइब्रेरीज चूज कर रहा हूं TSMC का, और वहां से मैं लेकर के आ रहा हूं PCH NCH. तो ये PCH NCH के टर्म्स में ना यहाँ पर कंपनी ने थ्रेशोल्ड वगैरह सब कुछ सेट कर रखा है, कितना इलेक्ट्रॉन्स रहेगा, कितना होल्स रहेगा डोपिंग के बारे में। तो हमें उसके बारे में नहीं जानना है, हमें पता है कि उनके थ्रू डेटा दिया गया है, तो हमें उस डेटा को ही यूज करना है, तब जाकर के हमारा जो चिप हम बनाना चाह रहे हैं ना वो 65 नैनोमीटर टेक्नोलॉजीज पे, वो 65 नैनोमीटर नोड्स पे वो सक्सेसफुली अकम्प्लिश्ड होगा। So let's do the designing. I already discussed the simulations of inverter from my first lecture. So we'll do again because we are doing the technologies notes we have changed on 65 nanometer technology. So let's start the lecture. So, okay, yeah. So you can see this layout. So first of all, I will close this layout because, and I made this circuit. This is inverter one tutorial. Okay. So quickly you can connect. See, quickly you can connect your PCH Mac, MCH Mac, V in, V out, VDD and GND. So I just means हमारा जो भी particular instance है, तो instance TSMC nanometer से हम अपना data यहाँ से उठा लेंगे, whatever the data you want to store. And see, remember one thing, that this PCH value na, we are putting as a 200 nanometer. It's 200 nanometer, and this one is also 200 nanometer. So we need to increase the size of this. So make it as 400 nanometer. Okay, if you will make this as a 400 nanometer, it will be good. So this is the tutorial. This is what we had made. Okay, and yeah, this is the symbol we have generated. So I know, I hope you know how to make the symbols and all. And okay, so this symbols, it's very easy. You need to go and create. So let me show you how we generate the symbol. Create cell view. From cell view, it will load. So we can modify because see, we already made the symbol, that's why here it's coming like this. From cell view, okay, replace करते हैं चलो. V in, command X, and bottom pin is, so left pin V in, right pin V out, and bottom is G and D. So by this it will come, and you need to delete this instance. You need to put inverter. I'm giving like this name, and I'm deleting this. This I'm deleting. So now you want to, your, so your inverter, it's very easy to make the symbol. So see, it's not coming actually. Okay, see, we are not selecting properly, as the things happening. So let me delete this, let me check this. Okay, so this was the, we are taking the ellipse, that's why. Okay, keep it like this, or if you want you can move further. or keep it like this, because we are going to learn the layout, so I'm not focusing on the perfections of the figure. If you want to make it more perfect, you can make. And you can selection box as automatic you can give. So this is what we got, the inverter. Okay, circuit. Now we will create one file. I already created inverter tutorial check file. Okay, so in this tutorial check file, we will give the supply as a VDD, ground, and the capacitor value femtofarad. Capacitor we had set as 100 femtofarad, and the pulse we give as 0 1.8 1.8 v1 voltage, voltage v2 is minus 1.8, period 10 nanosecond, delay time 10 picosecond, very less. Delay is nothing but it's taking some delay to for the input, and the rise time to getting up to the high value, it's taking 10 picosecond, and and falling up to its low value, it's taking 10 picosecond. And pulse with set at 5 nanosecond. So this we set, and this is what we had given the supply as a 1.8 volt. So we will do the ADL, launch ADL, and we'll check whether this graph is working or not. So simulations. So first simulation से पहले we need to add the libraries SCS file. So I'm deleting this. Have I will add one file, and yeah, you will get all this file in your PDK SCS file. Okay, so I already copied it from there only. Okay, now okay, now I've done one mistake. Let me correct. Here you have to give the, you are doing for what. So I'm selecting for TT, transient, and analysis. We are doing a transient analysis up to 100 nanosecond. This is moderate, okay, and output to be rotate select on design. So these steps is just to show the schematics quickly, and here we are going to run the signal, and we got the output. So you can check. So rising and falling time means it's a peak to peak value is minus 1.8 to 1.8, and the output we are getting 0 to, it will not be completely 1.8. It's have some losses, because discharging while charging the current from VDD, the PMOS will get some amount of power consumption. Power loss will be there. So from there, the voltage drops, we are getting a lesser value. And here the complete value is 0 as a negative, because it's completely discharging when your NMOS is getting on. So by this way, by this logic, I already explained how it's work. So this is the just a simulation, simple simulations to show you all. Now we'll move towards the layout. So let me close this, and let me close this one. So this was the symbol where we had the schematics where we have created. Now we'll launch the layout Excel. In that layout Excel, we will create. I already have the design, but I am teaching you, I am demonstrating you how to make the layout. Let's start from the beginning. Okay. Yes. So this window will open. Now what you have to do, first you do one thing. Go to your display section by pressing E, and make sure that your minor spacing value is 0.005 and the major spacing value is 0.05, and X snap is 0.005 and Y snap is 0.00. Then what you can do, you can call the instances value. So here you can select only instance, rest of all you can ignore it. Okay, so your instances will come. This is your PMOS and NMOS. Now move this vertically आप लोग move कर लीजिए. Actually this is origin, so we are keeping in this positive first coordinate. That's why we move this section. So see, here we have a lots of layers. So here blue layers is not nothing but it's a poly layer, polysilicon layer, that is your gate, and this is this greenish layer, it's your metal layer, that is your source, and that is your drain. Okay, this is PMOS, and here there is a substrate. Okay, so I hope you know the basics of this, how it's how what is substrate and how we create N well, P well. In your VLSI technologies classes, I hope you already learned this, or I will provide this classes, what is the meaning of N well, P well, and how we are doing these things. Okay, I can show you that also, but here we are demonstrating the layout, so I will keep up to this part only. So here you can see, so in layout how what's happened. So okay, just check this, what's happened and what we have to do. See, your source is connected to VDD supply S1, we call it as a S1, D2, D2, S2. So S1 is connected to VDD and D1 is connected to D2, and G1, this is my G1, this is my G2. So G1 plus G2 is connected to Vin, and your D1, D2 goes to Vout. So we need to connect all this. In this manner, we will not get the DRC error, that is design rule check. तो चलो कनेक्ट करते हैं फटाफट से. Close this. So how you will connect this? See, you cannot directly bring this polysilicon layer here to, as a down. You can do that. So यहाँ पे हमने polysilicon layer select किया, polysilicon raw layer. Then you have to press R. You can do that, but this will give you an error, DRC error. बिकॉज देखो ये जो पॉलीसिलिकॉन लेयर है ना, ये हमारा एक पर्टिकुलर एनपी लेयर पीपी लेयर के अंदर में प्रेजेंट रहता है, तो ये हम लोग इसको बाहर नहीं लेकर के जा सकते. हाँ, मेटल लेयर को हम बाहर लेकर के जा सकते हैं, लेकिन पॉलीसिलिकॉन और मेटल लेयर को कनेक्ट कराने के लिए हमें वाया यूज करना पड़ेगा. वाया एक ऐसा टूल है या फिर एक ऐसा टर्मिनल है जिसमें आप दो वायर को कनेक्ट कर सकते हो ऊपर से नीचे. तो वील प्रेस ओ एंड वी हैव अ वाया. तो लॉट्स ऑफ वाया इज देयर, सो वी आर मूविंग. पॉली से हम मेटल में जाएंगे तो हम M1PO यूज करेंगे. ओके, तो हमने ये M1PO का वाया यूज कर लिया. नीचे में भी हम इसी वाया को यूज करेंगे. नाउ वी कैन इजिली ड्रॉ द मेटल लाइन. फॉर दैट वी आर सेलेक्टिंग M1 draw. This is our metal line. Press R, so you will get a rectilinear step. Okay, see, in layout na alignment is very important, so please take care of that and move. Okay, you can do that also. You can press A, you can press this, so you will get the proper alignment. Okay, see, for alignment you need to make like this. See, press A, see what we are doing. We have to make the proper care of the alignment. or first we delete this. Let's move this. Delete this. Okay. If you want, see, यहाँ पर अगर हम A दबाए और इसको A दबाए, तो it's getting properly aligned. Okay, properly aligned. But these two cannot be connected together. But one is PP and one is NP. So we are just shifting some words up, and we are calling shifting our via by M. You need to press the M, and you after that you can use the mouse. Okay, so via is there, and we'll take another via. Simply I'm copying this via and I'm placing here. Now you can take your metal line M1 and you can connect the metal line like this. Okay, so this M1 connected. Now how you will connect your VDD? This is D1 or this is D2. So for that, a rectangle, you can take like this, and the width should be greater than 0.9. Okay, otherwise you will get the DRC error. So K, it's 0.115. So we have connected our VDD. VDD is connected. Now what you have to do? See, we need to create the body of this. So body, how can we create? So by pressing Q, you will get the property of this. So here we can go inside the parameter, and there we can select the body. So you can select as a right body, body type L. So we are selecting detached body. In detached body, you need to give the supply. So here the body is, we got the body. Okay, similarly you can do for this also. So parameter you need to check, and you need to get the, I'm setting as a detached body, left side. So here I have a left detached body. Okay, so we have connected DD, ground, body is there. Now we need to give the supply. So again we will select our metal line. Chalo, creating the metal layer. Okay, so मेटल लेयर के बाद आपको बॉडी में सप्लाई देना है. तो बॉडी में सप्लाई देने के बाद आपको यहाँ पे इसको भी सप्लाई देना है. Source is also connected to VDD. And check the width. How much width? This 0.09. So it's a perfect width. Okay, 0.09 से आप कम नहीं रख सकते. Similarly, we'll do with this metal line. We take the bottom metal line. Okay. And here also you need to give the connection. Okay. So suppose if you want to stretch, so by pressing S, you can stretch the line like this. Okay, H पे आपको जाके press करना है, and you can extend those all three. So this is what the design is ready. Now you have to give the pin. For creating pin, you need to create the pin. So create pin. So pin you need to select what is the function. So input output is your VDD and GND. So VDD will give and GND will give. Okay, and by considering the pin, you need to select as a M1 pin. So this is my M1 pin. So here I am creating my VDD, and here I am creating my GND. Okay, now again we'll go with create pin, and we'll select as a V in. Okay, V in, but what if this is my input? So input I am creating as a V in pin, and again create. This is very important step, pin, and you need to give as a. Please take care of that. What is output? What is, so V out? This is your V out. Then we'll do the labeling. So labeling we already, मैं पहले से ही V in V out VDD GND लिख रखा था, तो V in V out स्पेस दे करके GND आप लिख लो, and the size you can keep at as 0.1. so V in कहाँ पे कनेक्ट होगा? V in यहाँ पे कनेक्ट होगा, and you have to select the metal pin layer connecting, and V out यहाँ पे select होगा pin layer, and VDD यहाँ पे कनेक्ट होगा, this is your pin layer, GND यहाँ पे कनेक्ट होगा, this is your layer. So my layout is completely ready, but we'll check the DRC. तो DRC में हमें कुछ एरर मिलने वाला है, मुझे अभी पता है क्या एरर आने वाला है. I will show you. ओके, तो डीआरसी के लिए ना आपको दो फाइल चाहिए होता है. एक फाइल डीआरसी के लिए कैलिबर डॉट डीआरसी का फाइल होता है, तो ये भी आपको पीडीके के अंदर में मिल जाएगा. इस लाइब्रेरी को आप यूज कर रहे हो, तो मैंने पहले से फाइल को कॉपी कर रखा है. कैलिबर डॉट डीआरसी, जो भी पीडीके फाइल है आपके पास ना, उसके अंदर में मॉडल्स में जाकर के आपको कैलिबर के अंदर में आपको ये फाइल कैलिबर डॉट डीआरसी मिल जाएगा. और कहाँ पे आप इसका रिजल्ट सेव करना चाहते हो, यू कैन गिव दैट पार्ट. तो कैलिबर रन में मैं एक फोल्डर बना करके यहाँ पे रिजल्ट इसको रन कराना चाहता हूँ. सो आई एम रनिंग दिस माई डीआरसी. तो सी आई एम गेटिंग अ लॉट्स ऑफ एरर. व्हाट इज दिस. सो आपको ना एरर को फिर क्लियर करना पड़ेगा. So suppose I want to clear this error. I will highlight this. So what it's showing, adjacent edge width, the length is less than minimum, width is not allowed. So M1 via is not inside. Okay, so some error is there. So let's do something where we are getting the error. So आपको error ऐसे पता नहीं चलेगा. You need to highlight that. By pressing this and highlight this. So this is the error what we are getting. Okay, so see, तो इसको कैसे कम किया जाए भाई? ओके 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 ओके, हमने ये एरर तो कम कर दिया है. लेकिन अब चेक करता है कि ये एरर हमें फिर से मिलता है कि नहीं मिलता है. No, we are not getting that error. This is density error, we cannot do anything with that. डेंसिटी एरर आप एक इंडिविजुअल सेल लेकर के भी चेक करोगे तो डेंसिटी एरर देगा. जैसे जैसे आपका वॉल्यूम बढ़ते जाएगा ना, तो दिस ऑल आर द डेंसिटी एरर. वी कैन नॉट डू एनीथिंग विद दैट. दिस इज आल्सो द डेंसिटी एरर. prohibited. Floating gate is the effective source. Okay, this is, here we are getting one error, so it should be greater than 0.15 your enable, और ये मुझे पता है ये कहाँ पे एरर है, should be greater than 0.15. ओके, तो डिस्टेंस जो है ना वायो और इसका जो डिस्टेंस है ना, इट शुड बी ग्रेटर देन 0.15. सो वी नीड टू क्रिएट, दिस इज माय एनपी लेयर. तो इस एनपी लेयर को आपको थोड़ा एक्सटेंड करना पड़ेगा. एनपी लेयर दे करके हम इसको थोड़ा सा एक्सटेंड कर देते हैं, और सेम ऊपर वाले केस में भी हो जाता है. तो अब देखो कितना रख सकते हो, 0.15 बोला था ना, आप यहाँ पे रख सकते हो. तो इसको थोड़ा पीछे लेकर के आ सकते हैं. एंड सिमिलरली दिस लेयर इज ऑल्सो वेरी लेस, सो इसको भी हमें इंक्रीज करना पड़ेगा. दैट इज योर पीपी. ओके, और ये सब पता है कहाँ पर पता चलता है, डीआरसी में ही पता चलता है कितना एक्सटेंड करना है, क्या करना है. नाउ सी, ये केस से आप इसको मेजर कर सकते हो. देन प्रेसिंग एफ, देन विल रन डीआरसी. देखो यहाँ पर एक एरर आपको, जो डेंसिटी जो ये वाला एरर मिला ना, ये देखो ये भी वही एरर है जो मैं आपको दिखा रहा था, जो कि हमने एक्सटेंड कर दिया. रन डीआरसी करते हैं, काफी हद तक हमारा एरर कम हो जाएगा. लेट्स चेक. So density error we cannot do anything, this error we cannot do anything, and this is also we cannot do anything, this is also we cannot do anything, this we can do. Check m1 w1, it should be greater than 0.01. so where we are getting, पहले तो आप हाईलाइट को क्लियर कर लो, क्लियर हाईलाइट, बस. ओके, इट शुड बी ग्रेटर देन 0.09. तो हाइट हमारा कम छोटा हो गया. हाँ देखो ये काफी छोटा हो गया. अभी ठीक है. डू अगेन, ये थोड़ा प्रोसेस जो है ना, और मैं इसीलिए थोड़ा जानबूझ करके एरर रखा हूँ कि आपको सिखा पाऊँ कि एरर को रिजॉल्व कैसे करते हैं. सो सी, एडजेसेंट विड्थ लेस देन मिनिमम विड्थ इज नॉट अलाउड. ये आप देखो, वो एरर आप क्लियर करोगे तो आपको दूसरा एरर मिल जा रहा है, एडजेसेंट विड्थ इज नॉट अलाउड, ऐसे करके कुछ एरर मिल जा रहा है. सो हम क्या कर सकते हैं, वी आर रिजॉल्व नाउ. So density error we cannot do anything, this error we cannot do anything, CSR error we cannot do anything. So now the thing is clear. So इतने सारे जो एरर रहते हैं ना, ये इसका आप कुछ भी नहीं कर सकते. Okay, now what you have to do, your DRC is now clear. Now you want to, you can save that file. Now you can check your LVS. So for LVS also you need to get the file from the PDK. So I already have that file. Okay, and I will save this in LVS run. I will run my LVS. LVS is nothing but layout versus schematics. So it will check whether your layout is perfect according to schematics or not. So it's correct, means layout is working perfectly. And here you will get the schematics of that. Schematics diagram आपको यहाँ पे मिल जाएगा. So V in, VDD, inverter. Okay, you can check inside this. What is this? So this is one PMOS, NMOS. It's connected to source. It's connected to. So it's an actual circuit what you have mapped on the silicon wafer. Okay, now you can size the what the size of this my inverter. You can tell the inverter sizes from here to here. You have to measure. Okay, it's 2.505, and the width you can check like this, and you can multiply, and you will get some micrometer square, range of micrometer square, and that will be the area consumptions of one inverter. So that's how we have designed. So see, this is your body one, this is your body two. Body one is detached, body two is also detached. For that we need to give the अलग से हमें VDD की सप्लाई देना पड़ेगा इसमें, और इसमें भी सप्लाई देना पड़ेगा. फर्दर मतलब अलग अलग भी प्रोसेस है कि आप बॉडी आप कैसे कनेक्ट कर सकते हो. तो आई यूज दिस मेथड एंड आई अटैच माय बॉडी beside the ट्रांजिस्टर. सो आई होप कि आपको इस पहला जो लेक्चर आपको दिख रहा है उससे कुछ फायदा आपको हुआ. एंड अगर फायदा हुआ है तो यार अच्छी बात है, क्योंकि हमें भी अच्छा लगता है आप लोगों के साथ बातें करना, शेयर करना, ये सब चीज नॉलेज. लेट मी इंटरैक्ट विथ यू वंस. So guys, this is what how we teach, and if you like this video, please do like, share and support, because it's took a lots of time to create this kind of a video. And ये मेरा लेआउट का पहला वीडियोस था. तो जो भी आपको अगर लगता है कि कैसे किस चीज को रिजॉल्व किया जा सकता है, कोई भी पर्टिकुलर चीज के बारे में आपको अगर आपको आइडिया भी रहा ना, तो आप प्लीज डू कमेंट, मतलब बताना. और क्या मुझे फर्दर दूसरे लेक्चर्स के तरफ भी अगर मैं मूव करूंगा ना, तो उस पर भी आप मुझे अपना कमेंट सेक्शंस में एडवाइस दे सकते हो. सो दिस इज ऑल डिजाइन टेक VLSI, एंड हम डिजाइन टेक VLSI का इंडिया का सबसे नंबर वन एजुकेशन VLSI चैनल बनाने वाले. तो उसमें प्लीज सपोर्ट करना. आई एम फ्रॉम IIT रुड़की, एंड वट एवर द थिंग्स आई एम लर्निंग हियर, मैं सेम चीज आप लोगों को सिखा रहा हूँ यहाँ पे. बाय, टेक केयर, सी यू.